What are logarithms? Logarithms are just the inverse approach, just the opposite approach to indices. We know when we multiply a twice, then we get a square, like 10 square is equal to 100. This is the language of indices. But in logarithm we ask the same thing, how much will be the number of times for 10 to be multiplied to 10 to be raised, so that we get 100. Means in 100 how many times we must multiply 10 to get 100, and that is 2. So this language is logarithmic language. So in this section we need to find this exponent in indices. This is the value, the logarithmic value of 100, and we call this logarithm of 100 to the base 2 to the base 10 is 2. Logarithm of 100 to the base 10 is 2. So let us just discuss 2 or 3 more. How much will be log 10 to the base 10? So 10 to the power how much is 10? That is 1. Log 100 to the base 10 should be 2. Log 1 to the base 10 should be 0. Why? Because 10 to the power 1 is 10, and for this, because 10 square is 100, and for this, because 10 to the power 0 is 1. So we are just reversing the statement in the indices. So if 4 square is 16 is the language of indices, then logarithmic language will be log 16 to the base 4 is 2. Similarly, if log 1 by 4 is to be found, so according to indices, this is log 4 to the power minus 1 to the base 4. So this one will be the logarithm. This is a minus 1. Similarly, log 1 to the base 8 will be 1 is log 8 to the power 0 to the base 8. So this will be equal to 0. So this is how we determine the logarithm of different numbers. Then let us now study what is logarithm. Let us discuss about the types of logarithm. The logarithms are classified, they are categorized according to the base we use. We can use a base 10, sometimes we can use a base e, sometimes we can take any other base. If we have a number x whose logarithm to the base 10 is to be calculated, or another log x to the base e or log x to the base a, then these 3 logarithms will have different names. The logarithms are classified into 3 types. First one is common logarithm, when the base is 10. Next is the natural logarithm, when the base is e. E lies somewhere, it is an e is a irrational number. That lies between 2.5 and 3. You will study it later on. And the third one is the ordinary logarithm, when the base can be anything other than 10 or e, the logarithm will be called ordinary logarithm. So let us name log 1000 to the base 10. This is common logarithm. Log 20 to the base e. This is natural logarithm. And this natural logarithm is sometimes written as ln, L for logarithm, n for natural. So this is also written as ln 20. We do not mention e here, just write ln 20. It will indicate log 20 to the base e. And this common logarithm is also written as log 1000. When nothing is written here, you should understand that this is common logarithm and the base must be 10. When nothing is written but ln is written instead of log, then you should understand that the base is e. But in all other cases, in ordinary logarithm, you have to write log 81 to the base 3, log 64 to the base 2. All these are ordinary logarithms. Now types of logarithm is over. Let us go for the fundamental rules. These rules are extracted from the theory of indices. We had the first rule, a to the power m into a to the power n is equal to a to the power m plus n. And how is the logarithmic rule? Log m to the base a plus log n to the base a is log mn to the base a, means sum of two logarithm is logarithm of the product. Second rule, log m to the base a minus log n to the base a will be equal to log m by n or m upon n to the base a. Third rule, log m to the base a whole to the power n will be equal to n into log m to the base a. Fourth rule, log m to the base a, nth root of log m to the base a will be 1 by n times log m to the base a or log m to the base a divided by n. So we have the rules of indices accordingly. A to the power m divided by a to the power n is equal to a to the power m minus 1. This is looking analogous. Similarly, a to the power m whole to the power n is a to the power mn or m into n. So this is the product rule, and nth root of a to the power m is a to the power m upon n. This is the division rule. So these rules also count. Just in order that you will understand that these two are interrelated, I mentioned them. And what are these are the fundamental rules, and what others are the rules. Log 1 is 0 because base 10 or whether it is base 10 or anything else, that will be 0, because whatever here it is, suppose log a, we know that a to the power 0 is equal to 1, so log 1 to the base a will be 0. So log 1 is 0, it is the next rule. Then log a to the base b will be 1 upon log b to the base a. This is the next rule. That means log 10 to the base 2 will be equal to 1 by log 2 to the base 10. This is the rule. The other rule is log a to the base b into log b to the base c into log c to the base d will be just the common factors cancel, b here, b down, b up, c down, c up, they are cancelled. You finally get log a to the base d. One example of this, log x to the base y into log y to the base z will be equal to log x to the base z, as if these two cancel. So these are the laws of logarithm, and let us try to prove them. Suppose you get log 10 to the base 10 plus log 100 to the base 10. How much you get? Log 10 to the base 10 is 10 to the power 1, so 1, and this must be 2, you get 3. And how much is log mn? Log 10 into 100, this is equal to log 1000. Since the base is 10 here, so this is equal to 3. So these two are equal. We get this rule. Suppose we take a minus. Log 64 to the base 2 minus log 32 to the base 2 is, it is 2 to the power 6 minus log 32 is 2 to the power 5. So this is 6 minus 5 is equal to 1. Now see how much is log 64 upon 32 to the base 2. This is equal to log 64 upon 32 is 2 to the base 2 is equal to 1. So these two are equal. So this is also proved. Now see, suppose you get log 100 to the base 10 whole to the power square. Suppose you get, this rule is log m to the power n, sorry, this should be log m to the power n. So log 100 square to the base 10 is log 10 to the power square, square of 10 square to the base 10. So this is log 10 to the power 4 to the base 10. So this is equal to 4. We get 4 as a result, but how much will it be directly? Log 100 square is equal to 2 into log 100, base is 10. So this is 2 into log 100 to the base 10 is 2, so equal to 4. So we got the thing true. Next, go for the next one. Log 64 to the base 2, take the third root, to the base 4, take the third root. So this much is cube root or third root of log 4 cube to the base 4, because 4 cube is 64. So this must be log 4 cube to the base 4 is 3, and you know this is not the rule, cancel kar diya. And now we are going to prove these fundamental rules. What are the rules? First rule is log m to the base a plus log n to the base a is log mn to the base a. What does this mean? Sum of two logarithms, sum of logarithm of a number and another number is logarithm of the product. So sum of logarithms is equal to logarithm of product. Let us check if it is true or not. Log 64 to the base 4 plus log 16 to the base 4 is log 64 into 16 to the base 4. Let us check it. LHS is log 64 to the base 4 plus log 16 to the base 4 is equal to, this is 4 cube log 4 cube to the base 4 plus log 4 square to the base 4. So this will be equal to 3 plus 2, which is 5. And how much is this much? RHS is log 64 into 16 to the base 4 is equal to log 4 cube into 4 square to the base 4 is equal to log 4 to the power 3 plus 2, 4 to the power 5 to the base 4 is equal to 5. So these two are, they yield the same result. So we got sum of logarithms is logarithm of product. Let us go for the next formula. Second formula is log m to the base a minus log n to the base a is log m by n to the base a. Let us check it. The same thing, log 64 to the base 4 minus log 16 to the base 4. How much is this? Log 4 cube to the base 4 minus log 4 square to the base 4. This much is 3 minus 2, which is 1. And here you see log 64 upon 16 to the base 4 is equal to log 64 upon 16 is 4 to the base 4, which is also 1. So LHS is RHS, that means this is true. Now let us go for the third rule. Log of m to the power n to the base a is n into log m to the base a. Let us take an example. Log 10 to the power 5 to the base say 10 is equal to 5 into log 10 to the base 10. Let us check if it is true. LHS is log 10 to the power 5 to the base 10, which is clearly equal to 5, and RHS is 5 into log 10 to the base 10, which is equal to 5 into 1 is equal to 5. So we got the same result. Now let us go for the fourth result, fourth rule. Here we have nth root of m to the base a, log m nth root of m to the base a should be equal to log m to the base by n. Let us take an example. Log say 1000. Let us take fifth root to the base 10. This much is log 10 to the power 5, fifth root of 10 to the power 5 to the base 10, which is equal to log 10 to the power 5 by 5 to the base 10 is log 10 to the power 1 to the base 10 is equal to 1. And how much is RHS? Log 100,000 to the base 10 divided by n is 5. This much is log 10 to the power 5 to the base 10 divided by 5 is equal to this much is 5 divided by 5 is equal to 1. So this rule is also true. Next, let us go for the additional rules. Log a to the base b into log b to the base a is equal to 1. Log a to the base b into log b to the base c into log c to the base t is equal to log a to the base d. So let us prove these two. Let us take a is equal to 100 and b is equal to 10. What does the first formula give? Log 100 to the base 10 into log 10 to the base 100. So here we get log 10 square to the base 10 into here we get log root 100 to the base 10. That means 2, this much is 2 into root 100 is also to the power 1 by 2. So this much is 2 into 1 by 2, which is equal to 1. So this one is proved. Let us take A is equal to 100. Let us take A is equal to 1000, B is equal to 100, C is equal to 10 and D is equal to 1, or take one more 0, and let us prove this rule. Log 10,000 to the base 1000 into log 1000 to the base 100 into log 100 to the base 10, log B to the base C, log C to the base 10. This much. We can write this much as 1 divided by log, no, this is not needed. This is equal to log 10 to the power 5, 10 to the power 4 to the base 10 to the power 3 into log 10 to the power 3 to the base 10 to the power 2 into log 10 square to the base 10. So this much is log 10 to the power 4 to the base log 10 into log 10 to the base 10 to the power 3, so that this remains as it is, and this much is log 10 cube to the base 10 into log 10 to the base 10 square, and this much is 2. So here we get 4 into, this is the reverse of inverse of log 10 cube to the base 10. This much is 3 into this much is 1 upon log 10 square to the base 10 and into 2. So how much we get? This much is 4, this much is 1 upon 3 into 3 into 1 upon 2 into 2. So this much is 4, and RHS should be log 10,000 to the base 10, which is equal to log 10 to the power 4 to the base 10 is equal to 4. So we get the same result. This seems a bit complicated for you because you are studying the same thing on the same day, and this should have been taken in 2 different classes. So let us go for this some time next. We shall revise this thing once again. First of all, you take the note of this formula only. Log A to the base B into log B to the base A is equal to 1. If you just follow this rule, then you can also write log A to the base B into log B to the base C into log C to the base D. You can write this as, say we want to take the reverse thing. So you take log A to the base B into 1 upon log C to the base B into 1 upon log D to the base C. You can also simplify this. When you have numbers here, then you can easily understand it. So let us keep this one for the next class, because it is the level 3 one, level 3 type. So we conclude with this formula only, which is required up to class 10 level, and the higher level ones are for the next competitive exams. So let us conclude with this, the fundamentals rules and the additional rules, and thank you for watching this video.